Welcome to The Explainer. Today, we're diving into a story of incredible scientific foresight and, honestly, devastating global disaster. We're going to examine a massive climate event from 2006 that pushed the world to its breaking point, pretty much exactly as scientists warned it would.
So what exactly connects a historic Australian drought to devastating East African floods? It sounds kind of like the setup to a strange riddle, right? But the answer actually lies at the heart of one of the most chaotic years in modern climate history. It's a mystery that stretches across oceans, and it fundamentally altered millions of lives.
Well, to figure that out, we have to look back at the sheer scale of 2006. It was a year absolutely packed with these extreme, seemingly disconnected disasters. You had Australia suffering its worst drought in a century. Right next door, Indonesia was getting choked by a severe drought of its own, massive forest fires in this hazardous haze. Meanwhile, on the complete opposite side of the Indian Ocean, East Africa was facing its worst flooding in 50 years, and India was just getting battered by an alternating nightmare of severe floods and crippling droughts. So how did all of this happen at exactly the same time?
Part 1. The Indian Ocean Dipole. To solve this global mystery, we've got to look to the ocean. The Indian Ocean Dipole, or IOD for short, is basically an El Niño-like climate phenomenon, but it occurs right in the Indian Ocean. And what's absolutely fascinating here is that this was a newly discovered phenomenon at the time. It was only revealed in 1999 by Dr. Saji and Professor Yamagata's group at JAMSTEC in Japan. Because it was so new, a lot of people, and frankly a lot of governments, were completely unaware of its destructive power.
Okay, let's dive into this. Think of it like a giant oceanic seesaw. In a positive phase, which is exactly what triggered all that 2006 chaos, shifting winds cause ocean temperatures to become unusually cool in the eastern Indian Ocean, near Indonesia and Australia. This pushes the warm water and the massive storm clouds that come with it all the way west toward Africa. The result? Cracked earth and drought in the east, and catastrophic rainfall in the west. It's just a massive, destructive cycle.
Part 2. Predicting the 2006 crisis.
Now, what makes the events of 2006 so uniquely tragic is that scientists actually saw this global threat coming months before a single drop of extreme rain ever fell. The global sea surface temperature forecasts were stamped December 1, 2005. By analyzing that data, the JAMSTEC ensemble models accurately predicted that a massive IOD event would return within 6 months. They were looking at the warning signs in the dead of winter in 2005, sounding the alarm for the summer of 2006. Knowing exactly what was barreling toward us, these scientists went into overdrive with frantic early warning efforts. They didn't just quietly publish papers and move on, they shared information via intense personal networking. They were giving presentations at tsunami and winter monsoon conferences all the way from January through April 2006. They even spun up dedicated tracking websites offering daily satellite observations. And why this level of desperation? Because they were deeply driven by the ghost of the 2004 tsunami. In that disaster, early warnings given by a Thai scientist were tragically ignored. The JAMSTEC team knew fragile coastal countries were facing the next massive threat, and they were literally begging the world to listen.
Part 3. Watching the ocean change.
So, you might be wondering, did the models actually hold up? Well, satellite data from the early summer of 2006 showed clear color shifts off the coasts. Just as predicted way back in December, the initial shifting ocean conditions started to unfurl in the Indian Ocean. The engine of the dipole was roaring to life right before their eyes.
And then, things escalated incredibly quickly. By late August, intense, dark, cooler water moved rapidly northward along southwestern Sumatra. Coastal upwelling was taking a firm hold. The sea's surface temperatures were dropping fast on this eastern side of the ocean, stripping the moisture right out of the atmosphere and setting the perfect stage for a brutal drought on land. And this brilliantly illustrates how intense that shift really was. It triggered a massive biological response. The data from September 2006 shows extreme coastal upwelling pulling so many deep, cold nutrients up to the surface that it triggered huge, highly visible phytoplankton blooms off the coast of Java and Sumatra. The oceanic shift was so powerful you could literally track the explosion of biology from outer space.
Part 4. The global fallout. Because, as we know, what happens in the ocean absolutely does not stay in the ocean. The scientific models were right, the satellite data confirmed the shift, and then came the terrible human consequences on land. The staggering geographical spread of this chaos was just mind-blowing. This wasn't just an isolated Indonesian drought or a localized African flood. We're talking about coral bleaching all the way down in Madagascar, an unusually hot summer in Japan, severe flooding in Thailand, Myanmar, and southern China, and a choking, hazardous haze draped all across Malaysia and Singapore. the entire Indian Ocean basin and vast regions way beyond it were thrown into complete climate turmoil.
Let's actually trace how this whole thing played out chronologically over the year. In spring 2006, we had those spot-on predictions and frantic early warnings. By summer 2006, the ocean shifted exactly as modeled. The eastern Indian Ocean cooled and the drought began to take hold. Then we hit autumn 2006. The IOD reached its absolute peak. We saw the outbreak of severe floods, out-of-control wildfires, and the rapid spread of deadly diseases. The real-world consequences perfectly and tragically mirrored the changing oceanic data.
The heartbreaking contrast of these extreme localized effects is just staggering. On one side of the ocean, people were standing on deeply cracked, parched earth in Australia and Indonesia. On the other, families in East Africa were stranded by catastrophic, muddy floodwaters, their absolute worst flooding in half a century. It's a massive, life-threatening deficit of water on one continent and a deadly surplus on another, all linked by the exact same ocean.
To put that abstract science into a horrifying reality, consider this staggering statistic. Because of the severe drought brought on by the IOD, the forest fires in Indonesia, sparked both naturally and by slash-and-burn farming, burned so intensely that if you added their emissions to Indonesia's national total, the country would have become the third largest CO2 producer globally that entire year. On top of that, the fires threatened biodiversity and created serious health and security issues across the whole region. The sheer scale of the destruction is almost hard to wrap your head around.
Part 5. The Cost of Ignorance.
The wild thing here is that the science was remarkably sound. The warnings were explicit, literally months in advance. Yet because virtually no preventative measures were taken, millions suffered immensely. 1.8 million people were affected by flooding in East Africa alone. In places like Kenya, Somalia, Ethiopia, and Sudan, an estimated 300,000 people were evacuated as raging floodwaters completely washed away bridges and roads, which crippled air-based aid distribution facilities. This standing water led to terrifying health crises, including a severe outbreak of Rift Valley disease. And across Asia, the drought and haze caused severe health, security, and massive economic losses. Famine, disease, death, all of it predicted, yet virtually unstoppable because the warnings just weren't acted upon.
So the crucial point of this entire explainer really boils down to this one powerful idea from the researchers themselves back in 2006. Learning from education is less costly than learning through tragedy. The scientific community tried desperately to educate. They tried to share the data. But the world just wasn't quite ready to recognize or act on this newly discovered climate phenomenon until the tragedy was already breaking over their heads.
Which leaves us with a pretty vital question. When the next major Indian Ocean Dipole or El Niño event is predicted by our incredibly advanced climate models, what are we going to do? Will society finally listen to the science ahead of time and take real preventative measures? Or are we doomed to just wait for another catastrophe to force our hand? Thank you so much for joining me for this explainer. Keep questioning, keep learning, and we'll see you next time.